Hello and welcome. This is another C4 an Excel video for A2 Maths. Now, in this video, I'm going to be giving you a bit of an introduction to vectors. First off, I'm going to talk about vectors and scalars. So, for those of you that have done physics last year, this should be a walk in the park, quite literally. And then I'm going to be going on and giving you a few types of vectors. So I'll be mentioning a standard vector, which is sort of, when I talk about vectors and scalars, I'll mention it then. I'm going to be talking about column vectors, which is something you do at GCSE. You did at GCSE, so again, walk in the park. Something called unit-based vectors, which is taking it up a little bit of a notch, but it's more the wording of that's more confusing than what it actually is. And then 3D unit-based vectors, which is actually getting a little bit more confusing now. But again, it's quite simple. It's more the wording that gets you than the actual. Once you understand what it is, it's very easy to remember. It's not loads of different things that you have to remember. It's just one thing. Well, three actually, but never mind. And then I'm going to talk about the difference between position and displacement vectors. And then I'm going to be just giving a mention to equal and opposite vectors. And showing how to they mask them in terms of parallelogram. But apart from that, nothing really extra. So as I said, in this video I'm just going to be covering just a few terminologies and introduction to vectors. So it's not going to be that heavily maths orientated, it's just going to be a bit of knowledge really. But I'm not going to be doing any questions as I did in the last video I put up, where I talked about the trapezium rule. I'm going to do a separate video for the exercises and the questions, because I just wanted to get through the theory in this video, because as I said, I want to keep it a bit short so you get a bit of a break from listening to me. So you can pause it now and walk off and make yourself a cup of tea, but I'm quite excited, so I don't want to excite you too much, you know, so I don't want to keep you from being unsociable. So anyway, let's kick off. So what's the difference between a scalar and a vector? Well, a scalar is something that just has magnitude. So just 3 newtons, for example, that is a scalar. No direction, no movement, we just said it's 3 newtons. That's a scalar. So in other words, it has a force but no direction of this force. However, a vector is the BT, the Meephy one. Meephy? The vector it'll be something like 3 newtons to the right. So therefore, that's a vector, because it has both magnitude and direction. So tickety tick tick for that one. So that's a vector and that's a scalar. Now, I don't think it would ask you, so give an example of a vector or a scalar. But there are some things that are closely related, such as velocity for a scalar, because it's got a magnitude and direction, and speed for a scalar, which is just someone running at 4 meters per second. No direction, just saying that. So a scalar is a lazy one, really. So that's a scalar and a vector. So I told you it's fairly standard. Now, so that was sort of really standard vector, where it's just a line and a 3 Newton force, for example. So that was a standard vector. A column vector is something you might have seen at GCSE. However, there are 2 types of column vectors. So there's one in 2D and then there's one in 3D. But I'll explain the one more in 3D when we come to talk about 3D unit-based vectors, because I think I kind of touch on that if I start mentioning 3D column vectors now. So you may see something like where it says draw the column vector 4, 3. Now this might be from the origin or whatever. Now if you're at the top one is how much it goes left or right. So if it's positive, it goes right by that amount, or if it's negative, it goes left by that amount. The bottom number, the 3 in this case, goes up by 3 or down by -3. Down by 3 if it's -3. So that's a column vector. So I won't go too much into that or draw that, because as I said, GCSE thing, so it just should be just a quick recap more than anything. That's what column vector is. Now a unit-based vector, this is a little bit more difficult. It's not that much more difficult. So say we've got some axes like this. Standard x and y, favourable axes. However, in terms of a vector, they're not just called x and y. We have unit base vectors. So unit base vectors is a fancy way of saying 1. A vector that has 1. So when we say has 1, it means goes in the direction by 1. So in this case, we'll call this I. I is to the right by 1 along the x-axis. So plus I is that way, right. And obviously, therefore, negative I is going to be in the opposite direction by 1. Because there's not going to be... So you could have 3I, which would be 3 this way, but I can only be 1, because it's a unit-based vector, which is, as I said, a fancy way of saying 1 in a given direction. A vector that has a magnitude of 1. And then in the y direction, we have one called j. And again, that has a magnitude of 1. So plus j is up 1, and negative j is down 1. So there are 2 unit-based vectors in 2D. So as I said, a unit-based vector is a vector which has a magnitude of 1 in a given direction. Now, what I'm just going to point out here, just because you might not remember what I and j is, because x, so x is before z in the alphabet. So as long as you remember what letters and numbers we have in here, so x is before y, and I is before j. So x goes with the earlier one in the alphabet. So x goes with I. So therefore I is along the x direction. And as j comes after I, it goes, and y comes after x, then y is with j. So j goes in the y direction by 1, because don't forget, they're a base vector of 1. So that's just what a unit base vector is. However, now we have to talk about 3D unit base vectors. Now we're going to introduce sort of a new parameter, if you want to think of it that way. So we said y and x. Okay, now I'm going to draw, so we'll call this one y. Okay, and then this one x. They're still at 90 degrees to each other. There's still got this little right angle here, but it looks like y is sort of going into the board, just what I tried to draw on it. We've got this other one called z. Okay, and this z sort of comes up and out as we saw. So they're all at right angles to each other, so they're still all perpendicular, so they're all good. And we're still going to draw on our unit-based vectors, because this is the 2D plane, but we've just added another one that makes it in a 3D plane. So in the 3D, what I mean by plane is just how you look at it, so 3 dimensions. So we're still going to have our I, because it's the before y in the alphabet, and I goes with x. So it's going to be 1 in the x direction. And we're still going to draw our j vector, which is 1 in the y direction, because j comes after I and y comes after x. However, for this z, because it goes x, y, z in the alphabet, and I, j, and then the next letter is going to be k, so that's the vector in terms of the z direction. So therefore it's k in the z direction. So we have a vector of k, and that's still a unit base vector, it still goes up by 1, but it's in the z direction by 1. So that's why we call this a 3D base vector, unit base vector. They still have 1, but we've just introduced a new parameter that sort of goes up and out from the y. So if you can't quite see how that works, I'll just try and demonstrate it with a couple of pens here. So basically what we've got, say this is your x, this is blue one's your x, your black one's your y, so they're sort of like that, so it's sort of flat as you can see. But then we've got this z one, it sort of goes up, so it sort of looks like that. I don't know if you can quite see that, where it's sort of pictured like that. So you've got your z coming directly up, your x going along, and then your y going up. So they're all at right angles to each other. Tried to demonstrate that you've got right angle there, and then a right angle at the centre. So I just tried to do a representation if you didn't quite get what I've drawn on the board there. So, as I said, I becomes before j, so as x comes before y, I goes with x, and as y comes after x and j comes after I, therefore y and j go together, and as z comes after y and k comes after j, then z and k come together. So that's I've tried to do it in, so basically this is I, J, K in the alphabet and X, Y, Z. So they all go together in, so X goes with Y, X goes with I, J goes with Y, and Z goes with K. Whichever way you want to remember. I try to remember is in the order of the alphabet, because you can't not, it's quite hard to forget I, J, and K, and X, Y, and Z, especially when you start doing a few questions. Probably more when you start doing a few questions actually, you don't really remember it at the start. But that's how I remember it. Okay, so that's a unit-based vector. It's a unit-based vector. Now we need to go back to our column vectors, which I said I was going to introduce at this point. Now, going back to our column vectors, we said, well, the first one, we're going to call this, I'll say that's 4, 3, and then we stop there, but I'm going to add a new one in. We're going to call this, let's say, 2, for example. So what does this actually mean? So the 4 still is positive in that way, or negative in the X direction. The 3 is either going to be up in the Y direction, or down in the Y direction. And with this other one, because we've introduced this new parameter, it's going to be Z. So therefore this 2 is going to be the Z one. So therefore it's going to be positive in the Z direction or negative in the Z direction. But as it's positive, it's going to be, therefore, because, alright, okay, so try to explain this slightly different. So in terms of these vectors here, I, J and K, because I is in the X direction, we can, and I is across in the X direction by 1, therefore we can say this as 4i, 3j, remember to do the squiggly line underneath to show it's a vector, and 2k, because k is the vector of z. Okay, so they mean exactly the same thing. So that's one way of showing it. So therefore you would say, okay, well if you wanted to write it as a normal vector, therefore that would be 4i plus 3j plus 2k. Okay, so that's how you might write it in that sense. Now what I'm going to talk about now, so hopefully you get that, so really it's just adding another parameter, because we've added this z one, we have to include this in the column vectors, because we've added sort of a new parameter if you think of it like that. So hopefully, as I said, you get that. We're going to move on to something we call position and displacement vectors. Now displacement vectors, we denote vectors such as, so if we've got a vector here, starting at point A and going to point B, we say this is the vector A to B, because it's going from A to B. Okay? But we don't know where this A and B starts. So we don't know where A starts, we know where they are relative to each other. Say this is, if we're using this one over here, we know they are, it's either 4, 3 and 2, or another way of writing it is equal to 4i plus 3j plus 2k. We know the difference between them, but we don't know where they are on the diagram, on the graph. But, so therefore a displacement vector can be anywhere. This is a displacement vector, because A and B can be, A can be where x is 7,000, or x where x is 2. We don't know, we don't really care, to be honest, because the displacement vector can always change it. It's not fixed to one position. However, a position vector, very different. It always starts from O. So therefore we can always say A, in this case, is O. Or, so we're never going to have AB as a position vector. It's always going to be O to something else, or OC, OB, whatever it may be. B, A. So it's pretty good. So OC, it always starts on the origin. So if it always starts on the origin, this is the this is sort of like the path it follows in a sense. So it goes 4 in the I direction, or 4i, so 4 in the x direction, 3 in the y direction, and then 2 in the z direction. So therefore, because we measure this, it's essentially a coordinate now. There's a column vector as coordinate. So the column vector is going to be the coordinate of the other point of the position vector. So C, if that was C, therefore C would have, as O has the origin, because it has the coordinates 0, 0, if you go up by 3, you're going to have 3i, if you're only 3i in the 3 in the x direction. So you're going to have a 3, 0, 3, 0. But because we're going in the x direction 4, y direction 3, and z direction 2, we're going to be going 4 coordinates in the x direction. It's going to be 4, 4, and then the y direction is going to be 3, so it's 4, 3, but because we're also including the z direction, it's going to be 4, 3, 2. So therefore, the coordinate of C, or any coordinate, because it starts from the origin, so any difference, the path you have to follow is going to lead you to the coordinate. And because the path you have to follow is actually a coordinate, that becomes the coordinate of the second point, because you're starting from 0, 0, so any path you make will be put on this coordinate. So hopefully that's trying to make sense. So therefore, this OC, the second number, is always going to be the same as the vector, the coordinate vector. It's always going to be the same, because you start from the origin. The point you end up is always going to be a path you followed. So therefore, because the path you followed is the vector, your coordinate therefore is the vector. So therefore, O is going to be, C is going to be 4, 3, 2, because that's your path you followed. You went X direction 4, up 3, and in the Z direction by 2. Okay, so that's what we call a position vector. Now, this next part is quite a lot easier. So that's probably the hardest part of this introduction. So if you get that, that was great. The rest of the video is quite nice if you got that. But as I said, any questions on that, please do let me know, and I'll try and explain it and do another video. But as I said, hopefully I've covered it there. I tried not to repeat myself too many times, but I just wanted to get it across. Okay, so the next part we're going to talk about is we're going to talk about equal and opposite vectors. So equal and opposite vectors, so if we call 2 points 1A, 1B, and C and D. So if these are parallel to each other, they've got the same magnitude, we can say, because we denote going from A to B is AB like that, so therefore AB, A to B is going to be the same. You're going to have to put the same effort in as going from C to D. Okay? However, if they're opposite, then you can't say they're equal. But this would help you in a parallelogram where you're saying, okay, this length of side is going to be equal to this length of side. However, if they're opposite, so if we're going from D to E, if we're going from D to E, but then the same line goes backwards, but has the same distance, same magnitude, therefore we can say E to D is going to be the same. So this point is F and G, because we've got F is the same point at E, so F and E are the same point, and D and G are the same point. Therefore, E to D is going to be the same distance as negative FG. So if you did the negative route, if you go backwards from G to F, it's going to be the same as doing D to E, because that's what we said here. So therefore, E to D is going to be equal to the negative of FG. Going from F to G is going to be the negative of that distance. Okay? So that's equal and opposite vectors for you. So you can apply that to a parallelogram where you say, well, the sides are the same length because AB is equal to CD. So as I said, that was just more of an introduction into vectors. And it was more just a, okay, this is what vectors are, we're going to apply them using stuff you already know. And as I said, this was just quite simple stuff. So to recap what we've done, in this introduction, we said what a magnitude, we said what a scalar, what a vector was. We didn't really mention too many examples of vectors and scalars, but I just said velocity and speed. Magnitude. So scalar has magnitude, but a vector has magnitude and direction because it has sort of the magnitude, and then it is going in a certain way. So therefore, that's quite simple. And then we talked about unit base vectors, which have a unit of 1, a magnitude of 1. And then we talked about them in 2D, so that I is with X because it's start the alphabet. And then Y goes with Z, with K. I'm confusing, don't ignore that. So right, start again. So X goes with I, the vector of I, because it's a unit base vector of 1 in the X direction, and Y has a unit base vector J in the Y direction because X comes before Y and I comes before J, so there J goes with I, and therefore the new parameter we added was coming out of the graph, and we call that Z, and that vector, because Z comes after Y and the one that comes after J is K, so K goes with Z. And that's what we said about 3D unit base vector. And then when we translate that into a column vector for 3D, we actually, because to the first one, the top one in the column vector was left or right, then the middle, then the next one down was up or down. But because we introduced this Z idea, the one that sticks out of the graph, we had to incorporate a column for that. So therefore we said the last one, that is in the Z direction, positive up or negative down in the Z direction. And then we just went on to talk about this idea of equal and opposite vectors and negative vectors. So as I said, that's just an introduction really to vectors. It's nothing too extreme, but I don't think it's anything too easy either, because this idea was quite complicated, but the rest of it was fairly simple, especially if you've done physics last year. This is in Mechanics Unit 1, so I'm going to just copy this video over to M1, so there's not going to be that much really to do. So this covers C4 and M1, so I think there's obviously a little bit more to come in vectors, but that's sort of the start of it. Thanks for watching, and we'll see you in the next video.